Well, the preparation assignment, 3B. I was good till there, and my math, I kept coming up with 8, but I saw on the answer key that it was 8.733, and I'm going. Anyway.
Yeah, this one was a little bit of a struggle. It took me a minute to kind of figure this one out.
I understand what a percentile is. I guess I'm just my math. I was, like I said, I was getting 8, not 8.733.
So what were the numbers you were using to divide?
Well, let me flip back here. So yeah, the 5, 10. I was doing a spread between, so the 10 being the mean,
yeah.
5 being the standard deviation. So I was doing a spread between the 5, the 10, and the 15. And so doing the what did I do there? The value minus the mean over the standard deviation. And that's how I kept coming up with 8. So
did you go to that website? Whatever it's called, the probability wesite or whatever it's called. So I mean, how I did is I went to that website and I plugged in the 0.40 in the area.
Yeah, the applet.
And then I got the negative 0.253. So then if you take your 5 and you times that by the negative 2.53 plus the 10 is how you get the 8.7333.
Oh, okay. So you put.
So where you're probably fouling up is getting that negative 2.53, because that's where I was kind of hung up. And then finally I'm like, oh, I got to put it in that website. So I put the 0.40 in that website, which gave me the Z.
Mm-hmm.
And that's what allowed me to solve it from there.
And then with the Z, you backwards engineered it.
Yeah.
Right? So you did the 0.253 times this. Did you say the standard deviation? I'm sorry.
Yeah, the standard deviation, which is 5.
Yeah.
And then added the mean, the 10. Is that right, Susanna?
Yeah.
Are we close?
No, that's awesome. You explained that perfectly. Yeah, I was really confused on that one too. And then I went to the video, like they have a third video on the preparation, and I watched how he did that one, and I was like, duh, the applet.
Yeah, I always forget about the applet. That just screws me up.
Yeah.
So once you can figure out when to use that, then it becomes simplified.
So can I back up then? So it's 0.253 times
0.253.
Yeah, 0.253.
Yeah, and it's a negative 0.253.
That's what I did. Yeah, burn it. Times the 5, which is the
standard deviation.
Okay. Plus the 10.
Plus the 10.
Equals 8.735. Well, I'm not going to split hairs over that. That's closer than where I was, right?
Yeah, I think on a calculator you get the 8.75. I think that's what I got. But if you do it in Excel, I think you get the 8.7333.
Okay.
So I've kind of changed over to, I use Excel basically for my calculator and all this.
Got it. That makes sense. Okay.
And I've cut onto Susanna's trick. I'm trying to make formulas. So like in today's homework, I made a formula to plug all those numbers in so it would spit out my answers without.
Seriously?
So if I got my numbers right, then it would do the math for me. So that's what helped me kind of get through the homework, is I got my formula right, and then I was just very careful where my numbers went, and it would spit out the correct answer every time.
Gotcha. I gotta maybe need to invest some time in doing that.
Susanna probably has like a really beautiful designed Excel spreadsheet that she spent probably 20 hours on, but I have a very basic one too that we could send you to that you could play with.
I'd be grateful for it. I would. I appreciate it. Can I ask another one?
Yep.
I had trouble with 3E. This one. Yeah, this one I had trouble with.
Okay, so did you solve 3D?
I did. Yeah.
Okay, so 3E, because they're asking for, because you already figured out what was greater than 12.
Right.
So now they're just less than 8, which is exactly the same as the greater than 12. So your answer on D, you just times it by 2. Because both sides are the same.
Oh.
So 12 is 1 standard deviation from the mean, and 8 is a -1 standard deviation from the mean. And then if you remember the 68, 95, 99.7 rule, it says that, you get it. I'll stop talking.
Yeah.
No, you're fine.
No. Yeah, so I was going to say that's the other way of, after I kind of solved it that way, then I realized that rule. I'm like, okay, that's 1 deviation away, so you can do it that way too.
So if I can ask, so 10 is your mean, but I thought a standard deviation was the whole 5. So is it just within 5, or is it? You see what I'm saying? Because I think that's what's throwing me off is how could 12 be 1 standard deviation from 10 when the standard deviation is 5? So maybe that's the part of the rule that's throwing me off. Is it just within that 5? Am I making sense?
Yeah. Yeah.
So
now
he's
getting
picky. So this is where I turn it over to you.
I'm sorry. Because that's what I struggled with. I'm like, I ended up writing. Listen, I ended up writing it out longhand. I'm like, that doesn't make sense.
No, you're totally right, because it seems like 15 would be 1 standard deviation, right? And 5 would be the -1 standard deviation. That totally makes sense. And I'm trying to figure that out too, because I'm not exactly sure why that is going on. But let me calculate the z-score.
Yeah, see, the only reason I figured that out is I remember in either the reading or one of the videos that he just took the one side and the other side was equal. And so that's the only reason why I figured this way out. I didn't go into it like you are saying, if the standard deviation is 10 and 5, why is 12 and 8? I didn't care to solve that because I got the right answer doing it this way. So I'm glad you're asking these questions because it'll actually make me understand why.
Sure.
Instead of just figuring out the right answer. So,
because I agree with you. Like, I see that now. The D, I had it for 12, but why? How would that be for 8?
Yeah.
All right, so I just calculated the z-score, and the z-score is 0.4 for 12. So then I'm just going to plug it into the applet. And so...
Yeah, you should get 0.3446.
Yeah, let's see.
-0.4.
Okay.
I missed that. 8 would be a -0.4.
And you're just wanting the greater, so you're just wanting the right side.
Okay, so then just the greater than is
right
0.3446.
So if you look at that chart, then it's saying then the less than the 8. So that's why if you just double it and click on the other side, then there you go. That's how I did it. So
yeah.
So the reasoning behind the whole 15 or the 10 and 15, that kind of a thing. I just figured since they were doing the 12 that it was kind of a 8, 10, 12 type of a deal. And so each side was equal.
But you know what? If going above the mean, 2 up from the mean is 12. If that's 0.4, then it would make sense that going 2 down is negative 0.4.
Right.
Right?
And so by doing that, it's the same on both sides. They're equal. So if you do the greater than or the less than, they're equal.
Yes. Okay.
Yeah, I can totally see how you'd overthink that one. In fact, I think I did the same thing on that problem. I might have. And then after that, I was like, you know what? I can't rely on my own brain. I just have to rely on this stupid applet that gets it right every time.
Yep. Between the applet and my Excel file is the only way I can figure these out. The common sense behind it, dude, I have no idea. I just rely on these two things to even get me close.
Same.
And if they just gave me these questions without an answer sheet as well, I probably would have gotten them all wrong. But
yeah,
it so helps to have the answer sheet so that I know that what I'm doing is right. Which then, when it comes time for the quiz and they ask similar questions, then I can figure them out. If they didn't do that, then I'd be screwed. So at least that allows me to play around with it and figure it out. And then I just write in my notes exactly how I figured it out and what I did.
Right.
And then go from there.
Yeah, that's what I've been trying to do is write in there what I did. So that way I can – my memory is not much these days. There's only so much that can be retained up there, man, you know?
Yeah, you know they say you only use 10% of your brain. Well –
using 1 today.
I think it's my brain's about 99% full of just stuff. So I've only got 1% I'm working with. So
So on number 9, that question, I used standard deviation divided by the square root of the sample size. So it'd be 10 divided by the square root of 25, which equals 2. And then do I take the 2 and plug it into the applet?
Well, you gotta do the top part of that equation too. You gotta do the 50 minus the 45 first, because you gotta do the 50 minus 45, which is then divided by 10 in the square root of 25.
Hold on, all right. So 9. You're saying I gotta do 50.
Yeah, if you remember that new equation that they introduced us to.
Was that today in our reading?
Yeah.
Let me go back to that.
So this time you're actually subtracting the value and the mean on the top first before you divide the standard deviation.
Okay, so yeah, the value minus the mean, right?
Yep.
Over the standard deviation.
Yep. So you had the standard deviation correct. You just need to minus the value and the mean on top of it.
Okay, over standard deviation. And do we still divide by the square root of the sample size?
Yep.
That's all on the bottom line, right?
Yeah. Yeah, so your top line is just the value minus the mean, and then you divide that by, so in your example, 10 divided by the square root of 25.
Yeah.
Is the bottom part, and then you divide, your top part by your bottom part to get your answer.
Square root.
So when you do the 50 minus 45 divided by 10 and the square root of 25 equals 2.5.
And then you plug that into the applet?
Yep.
Up in the area, right? Or is that the z-score?
No, that's the z-score.
Okay, maybe that's where I'm missing it.
And then you put that in the z-score, and then it's greater than 50, so you're only clicking the right-hand side, and then that spits out the area above of what it is.
Okay. A whole step I was missing. I'm telling you, I'm like, what is wrong with me today, man? I was going back all the way to lesson 3 to try to figure out.
On Monday. On Monday, I was going all the way back from the beginning trying to figure this out, but a couple of things that Susanna said on Monday kind of made me think, and then for whatever reason today going through it, I mean, I was very careful in writing everything down and going step by step when I was watching those videos. That really helped. But then again, that just got me through the homework and the quiz. When it comes exam time, dude, I have no idea.
Yeah. I'm going to be relying on all my notes and Susanna's spreadsheet. I wish I could share my page and show you your Z-score 68, 95, 99.7 rule spreadsheet.
Mm-hmm.
Been using that thing a lot today.
Yeah.
Yay!
I don't know
I'm
how
glad
much because I'm brain dead today, but I've been in that a lot today.
Yeah. What I was hoping is since we get to do all this as a group, we could take exams as a group too.
That would be great.
That's a good idea.
Yeah,
I think we should do that.
Yeah, I mean, come on.
And I promise I got one more. I don't mean to take up all the time. Last one. Number 15. I know it's similar to, where were we? Similar to, we just did one like this. Oh, yeah, number 3, well, 3E. But it wasn't similar, so that's where I was stuck.
Okay.
Because now it's a sample size, and I'm like, ah.
So how I did this, actually how I did the homework and everything, was with 2 steps and 2 steps only. First, you find the Z-score, and then you use Applet.
Yep.
And that's it.
Okay.
But the tricky thing that is really not that bad, you have to find out if they're talking about a single value, like, let's see, a single value or the entire sample mean. So for number 15, it's talking about the entire sample mean. That's the X bar. But once you know that, then you can use the proper Z-score formula.
Okay. So can I ask this question then? For finding the Z-score on a problem like this, I got to find the Z-score for both the 37.5 and the 42.5, right?
Yes. Well, I think that's what they want you to do. And it would probably be a good idea. Sorry, Jared, are you going to say something?
I'm leading exactly what you're going to say, so you can finish.
Oh, yeah. But I think they're both the same distance from the mean. So I think you only have to calculate one, and then you automatically know the other one is going to be negative.
See, this is how this is how you know, bring the 36 as the mean. It's not the mean. It's 40, man. All right.
Ben,
all right.
which one? What is your? Let's see. You're the ATM RM.
Yeah, that's me. That's me.
I'll send you.
See, I can remember my email.
That's a good thing.
That's a very good thing. I told my wife when she came home, I'm like, hey, if you find me wandering around down the street later on, okay?
Just like,
holy. No, I appreciate it, y'all. I don't know what is wrong with me.
I relied on you guys so much on Monday. I mean, I was so lost on Monday. Okay, so I just sent that to you. I mean, hopefully it'll make sense to you and you can figure that out, but that's just what I've been using. I'm sure Susanna has one that's way more clear than mine, but that's just what I've been using. So, I mean, you can...
Sure. Thank you. So, Susanna, as you were saying on 15, because of the same distance from the sample size, no, not the sample size, excuse me, from the mean, because the same distance from the mean, I really just need to find out the 1. And once I find out the 1, I can add them both together and get.
No, you don't add them both together.
You don't add them together.
It's just when you get the 1, then you already know that the other one is the opposite. So if you get the 37.5 one first, and that comes out as a negative, which comes out as negative 1.25, then you know that the other one's going to be a positive 1.25. Because the distance from the 40 is both 2.5.
Okay. Got it.
So
but what you're finding
the applet, then that's where you get your answer.
Yeah. So what you're finding first, remember, just find the Z-score. That's all you got to do.
I wrote it down. See, I did it.
Perfect.
Promise. I wrote it down. Oh, thank you. This has been a huge help. That's all I had. I promise.
When we start calling Susanna at 4 a.m. because we can't sleep over this stuff, then it's her fault.
Then I'll just start praying and asking for, I don't know, stupidity to wash over me. I don't know. Okay, you guys ready to tackle this quiz?
Let's give it a whirl.
Okay, perfect. All right, I'll just screen share. All right. I'll just read the first question. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. That is so easy.
0.175.
What is it? 0.1.
That's what I got. 0.175.
Yep. Yeah, we're rounding to 3, so.
Okay. 1.7. Perfect. All right. Do you guys just want me to keep reading them, or?
I can read it.
Go for it.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
Smaller.
Smaller standard deviation.
I don't remember reading that.
I'm looking back at my notes here. This is okay. Took samples larger. The standard deviation of sample means was always smaller than deviation. Smaller than deviation.
Yeah, we've never been stumped like this before.
Would it be the sample means? I'm looking back at Monday's lesson, 6.4. It says the standard deviation of sample means was always smaller than deviation. The mean of the sample means was always aligned with, what's that U thing?
The mean of the population.
Mean of the population, yeah.
Distribution.
So 9 observations from a population. That's what I'm thinking. B.
Do you think we can determine this, given the data?
Susanna, it's time to eat.
Well,
If 9 observations.
I
You think it's B, Ben?
do, because just me. 6.4, it talks about mean and standard deviation of the distribution of sample means. And it talks about the following facts are always true. They do not depend on the central limit theorem. They do not depend on sample size. These facts hold for the sample mean of any simple random sample of size drawn from a population with mean and standard deviation.
All right, so you're talking about the central limit theorem?
It says it doesn't depend on it. It says it doesn't depend on the central limit theorem.
Oh, okay, okay.
But as I read on here, it mentions that the mean of the sample means was always aligned with the mean.
Right.
The standard deviation of sample means was always smaller than the deviation.
Right. Okay.
And so that's what makes me think that it's which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population. I just
Oh
thought,
my goodness, you're totally right. That makes sense. Okay. I think okay, wait. I think I just caught on to what you were saying. Yeah. Okay, because the
I could
distribution
be
of the sample
wrong.
means.
We could totally get this one wrong, and then we get the second time, and then we know, right?
Well, hang on. The standard deviation of the sample is equal to the standard, so it's sigma divided by the square root of the number of populations, right?
Mm-hmm.
Yes.
So let's see. So that's going to be smaller than the standard deviation of the population.
Mm-hmm.
But then it's asking the distribution of the individual observations. Oh, the distribution of the individual observations is going to be the standard deviation, but the distribution of the sample means is going to be the standard deviation of the sample. So yeah, I vote B. I mean, makes sense to me. I don't know if that makes sense to you guys.
Does it make sense? No, but I like where you're going with this, so yes.
Well, hang on. Okay. Yeah, anyway. All right. Well, because if we had, let's just do an example. So like if we had a standard deviation, sorry, if we had a standard deviation for the entire population of like, I don't know, 10, and we have, you know, a sample size of 9, then we would just do, let's see, it would be the sample or the standard deviation of the population divided by the square root of 9, or the sample size. That's going to be 3.33 for the distribution of the sample means versus 10 for the individual observations. But I could be wrong.
Looks good to me.
I feel like it's B.
I like it.
All right.
I'll go with your gut.
Okay. Tonight I'm trusting my gut more than my brain.
All right, Jared, do you want to read this one?
Sure. Which of the following results implies that the spread in... Yeah, what symbol does that represent? I always forget.
X star? That's the mean of the population.
Is it the mean? Okay.
Spread of the population. Oh, sorry, the mean of the, the mean of the sample. Goodness, my brain's gone too.
Okay, so mean of the sample. I don't have these memorized yet. I use my notes. Spread in the mean of the sample decreases as the sample size increases. So which of the following results implies that the spread in... the sample size increases? Normal distribution, 68 rule, central line large. I just read that somewhere today.
Mm-hmm. Or was it last week? or not last week, this past Monday. So we're talking about spread versus shape, right?
Yeah.
So
So the spread is equal to the standard deviation, right? Is that what they're talking about?
spread decreases as the sample size increases.
Oh, that's a central limit theorem. Because
Reading that.
yeah, as the sample size increases, remember the central limit theorem, like how if you have a bigger sample size, then it'll be a bell-shaped curve. Wait, hang on. Law of large numbers. Yeah, I think it's a central limit theorem.
Now the central limit theorem definition: if the sample size is large, the random variable x will be approximately normally distributed. The sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large, over 30. Is it the same? Okay, the law of large numbers. If the standard deviation of the sample mean gets smaller, what happens to the values of x? The values that will be observed will be very close to each other and therefore close to, what is the U again? The mean?
Mean of the population.
Mean, if the sample size is large. So the law of large numbers states that the sample mean will be close to
So under there it says too, if the sample size n is increased, then the standard deviation of the sample mean will decrease. The fraction will get smaller. If the standard deviation of the sample mean gets smaller, what happens to the value of x? The values that will be observed will be very close to each other and therefore close to u if the sample size is large.
So the following results implies that the spread decreases as the sample size increases. The law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population mean. Isn't that what that is? The law of large numbers?
So the law of large numbers is talking about the mean of the population and the mean of the sample. The mean of the samples, right? So this is talking about the spread and the distribution. The spread of the sample means. Well, I don't know. I kind of, I think I want to choose C, and then if I get it wrong, then just go back and redo the whole quiz. But I don't know. What do you guys think?
This is tough. That's what I think. This is a tough one.
Even if the parent population is not normal, the central limit theorem guarantees that the distribution of the sample mean X will be approximately normal if the sample size N is large enough.
So spread decreases as sample size increases. Spread decreases.
Well, we know it's not A or B. So yeah, let's go with C and go to round 2 if we have to.
Mm-hmm.
Oh, okay. Thus, as the sample size increases, the standard deviations of the means decreases. And as the sample size decreases, the standard deviation of the sample's means increases. Okay, cool. I'm good with that.
I have to throw this out there just to confirm here. Lesson 6.7 at the bottom says the law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population mean. So our answer can't be the law of large numbers, right? Because it's asking us about decreasing, right? And the law of large numbers. Go ahead.
The law of large numbers is talking about the means. This is talking about the standard deviation.
Got it. Yep. I'm good.
Okay, cool. Let's move on. Use the following information.
Better, because this, I mean, we're only on question 6.
I think we'll start to be able to plug stuff into our handy spreadsheets. At least that's what I'm hoping. Okay, let's do this thing. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. I'm just gonna plug that in really quick.
Goes in.
8. Standard deviation 8.8.
All right,
okay,
so 160, what's the z-score?
Okay. So remember, this is just a single value. It's not talking about the entire population. It's just one.
Yep.
So you use a different formula, or well, the less complicated formula. So the z-score would be 1.0.
3 decimal places. Yeah.
Then you
just plug that into the applet.
Yeah. Wait, so then the rest we just plug into the applet?
Well, if I do that.
Yeah, you should.
For 5, and we're looking for the area where?
So 1.045. And it's larger, so just the right side. So that would be 0.148.
Yeah, that's what I have here. 0.148. Random sample. Oh, sorry. Are we done with 7?
I'm good. Are you guys good?
Yep.
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' scores? So we add those up, divide them by 5, and find the z-score for that mean, right?
Yep.
Divided by 5, so that's 160. So we already know what that z-score is, right? Or no? Yeah, be 1.045.
So is it the same? So it's the same thing.
I think so. Because the mean of those is 160, and it's asking what is the z-score corresponding to sample mean. Your answer would be the same as number 6, right?
But do we need to plug in the number of 5, Susanna?
Yes.
Yeah, so it's going to change because now we have 5.
Okay, so I got 2.337 or 2.338.
3.8. Any of you nervous about the prospect that the professor or the TA could join us on our call during the semester?
Heck no, because when he jumps on, he's going to see how much fun we have, and he's not going to want to get off. So.
Or you may not want to come back. You never know. So. Okay. Number 9, right?
Well, let's see. Hold on. So, Susanna, did you calculate beyond just the z-score? Because all they're asking for is the z-score.
Oh, whoops. Yes, I did. Thank you.
So it should just be the 2.338, right?
Yeah.
The next one will probably ask for what you're doing. There you go. So just the greater than. So now we can plug that in.
Perfect. Thanks, Jared. Appreciate it.
Yeah. So 0.0097.
That's what I got.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable which represents the sample mean of the 81 students who are selected?
So that would be approximate normal, right?
Yep.
See, this is where on Monday I was so confused, but I think I got it now.
Because it's equal to the parent sample, right? Or the...
Remember, this is left skewed. So the parent population is left skewed, but because n is greater than 30, it's going to be approximately normal.
Right. Okay. Yep. Because it's not dependent on the parent population, right?
Right.
Right.
As soon as it reaches that 30 threshold, it's not dependent.
Okay, what is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
Oh, so the mean of the means is the mean. That's easy.
I think I read that somewhere.
So if we go back up, yeah, 3.5, right?
Yeah.
This is where they kind of trick you. You act like you need to solve something, but you don't. You just need to pull it out of the equation.
Right.
Okay.
All right, cool.
Is there a difference? Yeah, there's a difference between...
Yeah, so the 12 is asking for the standard deviation now, not the mean of the distribution.
Okay.
So now we just plug that in.
Yeah.
4689.
Let's see. So I got 0.0778. Hang on, but I can recalculate to see if I'm doing it right.
Oh, no. I missed a step. Nope, I'm wrong. So 3.3. Okay. So negative 2.57.
Mm-hmm.
2.57.
Oh, wait, hang on. We don't have to calculate the z-score. We just have to calculate the standard deviation. Oh, that's super easy. No. Okay. Wait, what?
So, because it's asking for it less, so you calculate your z-score, and then you plug it into the applet, and then I got 0.0051.
Oh, which one are you on? Are you on 12 or 13?
13.
Oh, my bad.
Sorry, I thought you already had done 12.
I did. I just was like trying to make sure I did it right, so I redid it again and again. You're good. So you got negative 2.57 for the z-score.
Yeah.
Right? Okay.
7. And yeah, 0.0051.
Awesome. Oh, wait, we'll be less than 3.3. So we have to go the other side.
It's the other side.
Gotcha.
It's still the same amount.
Just negative? Oh.
It's
No.
0.9951.
Wait a minute.
I got 0.0051.
Students will be less than 3.3.
Oh,
the
wait.
mean is the 3.5. You only want the left side, right?
Oh, you're right. Oh, my goodness, you guys.
Yeah.
I'm brain dead too.
Don't worry, between all of us, we'll get through this.
You're less brain dead tonight, so.
Oh, goodness.
Question 14. Probability that the mean will be greater than 3.3. Well, that's the same, right?
Yeah.
Yeah.
Wait, will be greater than 3.3? Because at 3.3.
No, because now you do the middle.
Right. Yeah.
So now you do the middle and the right.
0.9949.
0.9949.
Not bad.
So I got 0.9951. Is that right?
Well, they want us to round to 3 decimals, so it's 0.995, right?
Oh, yeah.
Good eye, Jared. Good eye.
Yeah.
So the one above, you're going to want to do 0.005.
0.05. Ooh,
Oh, thank you so much.
I got that wrong. Did I do that anywhere else?
I did it on 12. I don't know about you.
So I'm glad I'm checking, because if we go back, question 8, sorry, don't mean to go back. This says round your answer to 3 decimal places. You guys might just want to. I don't know if I did that one right.
Well, I'm so glad you guys caught that. Because I really don't want to do this quiz again.
Love it. Okay. Number 15. I feel bad for whoever's going to watch this video later on because they're like, guys, just get there already. Come on. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction. A lot of information. The mean weight is 185. Standard deviation is 26.7. Does your Excel thing work for this?
No.
No?
Yeah. I'm hoping so. That's what I'm using it for. So the Z-score, I mean, if you plug those in, you get a Z-score of 1.92.
Oh. So 1.92. We're looking for it, was it above?
It's looking at, it says find the probability that a random sample of passengers will have a weight that is as extreme or more extreme.
Well,
I mean, if you do greater, then you got 0.0274. If you do same or greater, it's 97 point or 0.9726.
right. And then there's the note. We're not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
So if you take that, then you'd want just the right side, right?
Well,
What are you thinking, Susanna?
I'm still trying to wrap my head around it. And so for your Z-score, did you get 1.92?
Yeah.
Okay.
So then if you take just the right, because they're wanting, they're not, let's see, it means that we are not only interested in values that are lower than the ones we observed, but also, values that are as far away from the mean
as ours to
in
the right.
positive direction. So that would be the right only, right?
Yeah, wouldn't it just be, yeah, both?
Both the middle and the right.
Right. That's what I would think. So, yeah, that's kind of a confusing one. As extreme or more extreme.
Yep. I'm reading that as the center and also the right.
I like it.
0.973.
Okay, I'll go for that.
Dun, 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 dun. Here we go.
Did you submit it already? I'm scared.
Going to right now. Submit.
All in. All right, 15 out of 17.
Wait, which one did we miss?
So we just missed the last one we did.
We did?
Yeah, and then we missed number 5. It's not the central limit theorem.
Dang it.
Did you guys miss 12? I missed 12. How did I miss 12?
I did not miss 12.
What? How did I get
What did you put in as your answer?
0.778?
It's 0.0778. Or 0.078 if it's 3 decimals.
0.078. Ah, gee whiz.
Okay, this one was really weird. Which of the following results imply? So number 5 is not the central limit theorem.
No.
So would it be the law of large numbers?
Those were the two that we were debating between. So
Yeah.
Well, okay. So I didn't turn mine in yet. So what I'll do is I'll change my answer to the
what the-
law of large numbers, and then if we get it right, then
oh, hey, yeah, that's
then
smart.
you guys can like go back and like then we'll know that's right, right?
Okay, so change number 15. Did you
Yeah.
erase 15?
So let's change number 15. Okay. All right. So
Man, we should do that with everybody. We should only have one person submit it.
yeah, that's a
At a
good
time.
idea.
Sacrificial lamb.
Yeah.
Well, but they can go back and redo it,
True.
right? They can
Yep.
go back and just like fill in all the answers. That's what my aunt took this class, and she's like, yeah, just do that. So I think it's a good idea.
All right, we learned our lesson.
Okay. So for
So with
this
15,
one,
are we just going to do the right side only?
Well, seems logical at this point. I mean, apparently they're not interested in as extreme, right?
Or are we missing something?
okay, if I was this United States Coast Guard, why would I want to find the probability? Let me think. So they don't want their boats to sink. So they're wanting to know what the probability is that these boats are going to be 177.6 whatever pounds. Or the average, what?
Are you still there?
Me?
Yeah, I'm just doing my. Okay, you're good. You're good. You're still there. You got really quiet. Starting to feel like maybe the meeting ended like it did the other day, and I was sitting going, "Where'd everybody go?" I didn't do that part of the conversation the other day. I was like, "What?"
Oh, sorry about that.
That's okay.
My bad. Oh well.
Yeah, it worked. I was fine. I healed.
No hard feelings.
Nope, none.
Oh, good. Yeah, so with this thing, I don't know. I'm going to try plugging in the z-score of instead of, well, no, that wouldn't even work. Guys, I can't figure it out. I'm stumped.
Well, since you haven't turned in them, you can always try just the right skewed.
Like that?
Yeah. I mean,
so 0.0274.
because since you haven't submitted it yet, we have kind of an extra shot.
Oops. I don't think that's going to be it. I wonder if they're trying to.
I know. I think there's something more extreme to it too. Like one of those error ones that is like 0.000004.
Yeah, like way down there, like a
3
zeros and a 6.
What if I tried both the left and the right side? 0.055. I'm going to try that just because I don't know what else to do. 0.55. Right. Wait, hey, that was it. Whoa, you guys, hang on. Okay, that worked. Hang on. So it was both the left, the far left, and the far right sides.
That was the right answer?
Yeah. I got it right.
0.055?
Yeah.
0.055?
Yeah.
Oh.
Okay, and for number 5, it's
The large.
the law of large numbers. I don't know what. That one's beyond me.
Extremes, right?
Yeah. Wait, for number 5 or number 15?
15. You said law of large numbers for 5.
Mm-hmm.
Oh yeah. Yeah, law of large numbers for 5.
But yeah, 15. So
As extreme or more extreme.
values that are as far away from the mean as ours in the positive direction.
Oh, that makes sense.
Please share.
Okay, so our value is negative. Wait, that was it, right? Negative 1.92, right? What did we get for the z-score? Okay, so the z-score was negative 1.92, or sorry, yeah, 1.92.
1.92.
So then, as extreme, I read that as from way over to negative 4 standard deviations up to that z-score. So that's as extreme. And then or more extreme is positive 1.92 all the way up to a positive 4 standard deviations. Maybe that's just, I don't know, that's just how I'm wrapping my head around it. So it's as extreme or more extreme, not anywhere in between.
Can I say this is probably the most difficult one we've taken so far?
It totally is. This is
Yeah.
stupid.
This was tough.
Like the way you said it. Stupid.
This is the first one that we got one wrong.
Yeah. Do you guys want to like retake yours really quick? I'll keep my answers up and you can just like fill them in.
What? I'd already submitted it?
Well, because you have 2 chances, right?
Yeah, I did the second one and got 100%.
Woo!
Yep.
We're good.
Sweet.
We're good. Yes.
Okay.
Wow, that was crazy.
Hopefully those that watch this video stay with us to see these last 7 minutes, you know? Just hang in there.
Wow, and it's only been almost 2 hours. Hey.
For real.
Wait, what's that? Yeah, that's true.
Oh,
So
well.
it was productive. I've learned a lot tonight.
Okay, so we need to be able to take an exam together, so let's work on